stations on the Marnet. This is Flight Director. The DC-25 command has been transmitted to the...
My job was chief engineer for Mariner 4. We're sending a spacecraft from Earth to Mars on a journey that's going to last 9 months, half the distance to the sun almost. You're plowing new ground.
Stations, stand by for stats reports.
The launch was a little bit scary because maybe half the launches blew up on the pad, and there was a lot of other failures.
They have affirmed. Spacecraft scientists...
The reason people come down to watch a launch is they're hoping to see an explosion. It's usually the period of time where things, if they're going to go wrong, do go wrong.
6, 5, 4, 3, 2, 1, 0.
This thing could fail, you know.
Ignition. Liftoff. Going up. Roger. 1-3 seconds. Run away. Roger.
I think for Mariner 4, there's a great sense of hope. Mars has a sense of romance about it because it's a place, it's a planet, it's another world.
All stations, this is H1.
It's as close as we can see in the solar system to something being Earth-like.
Would like to report the spacecraft is unacquired.
You're doing something for the first time. The prospects and possibilities are really enticing. Are we alone? What story does Mars have for Earth? It's the stuff of dreams.
I think Mars has held the fascination of the public because we've had these visions, thanks to science and science fiction, that it was this place where there was a thriving alien civilization.
Percival Lowell wrote several books on Mars and its past civilizations. He talked of canals being built to transport water. Aliens and Mars have been hooked together ever since those early days.
I remember hearing when I was in grade school that there might even be intelligent life up there, might even be more intelligent than on Earth. It was just a total unknown.
People didn't know.
Welcome, number 1.
This is Mariner Control Center at JPL. Mariner 4 is 134.217 million miles from Earth and 50,142 miles from Mars.
So it's July of 1965, and we're about to have this encounter with Mars.
2815.
We received a signal that means the spacecraft had detected the planet.
0.74 degrees from where we wanted to be. Yeah, I noticed that. Did you get that?
We had all gathered together.
A lot of people have their fingers crossed. Other people are smoking cigarettes.
About 12 minutes from now, we should be able to determine that the recorder is running, although we will not be able to determine definitely whether pictures are actually being recorded on the tape until they are played back.
The flyby itself takes a matter of hours.
The spacecraft automatically took a set of about 22 pictures.
Picture will cover an area of approximately 176 miles square on the sunlit limb of the planet.
There's some cheering, but mainly it's just relief that, yeah, we did it.
What are we going to do when we see H-E-L-P stamped out in the snow?
The scientific instruments are sending back data, and that's of interest, but of course what we're waiting for are the pictures. The pictures were everything.
But
The picture-taking sequence was not precisely as predicted.
there were some anomalies in the telemetry.
The last I heard there was that there was some funny business in the first 10 picture recording.
There were extra stop record signals. So there was speculation that the tape recorder had started and then stopped early. The mission operators and our bosses, they thought the worst.
That TV system, which should have turned the tape recorder on and off, may have failed.
The next morning, we were wanting to handle the issue of proving to the bosses that the tape recorder was working. There was an artist shop on the way to work.
So they bought these crayons called pastels. They took them back up to JPL. This data is coming back out of a teletype machine. It's going chunk, 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 chunk. And then you had to take scissors and cut them up into strips and then mount those up on a board on the wall.
The numbers represented the intensity of light at 1 pixel. Each one of those numbers, he assigned a color.
And in that way, you assemble a paint-by-number picture. The picture was about 40,000 numbers. The word spread. Other people started joining in, cutting tape and coloring. And it took 8 hours to finish the picture. When we saw the final image, we had accidentally created a piece of art. And then a TV crew arrived and broadcast a picture.
You know, well, it represented the first image of Mars taken from any place but the surface of the Earth.
And it was really a stunning thing to see. The colors were vivid. It was very saturated and beautiful. It was really striking. So when you finally saw the real photographs,
Face down, right?
Yeah, face down.
it was this horrid-looking, gray, dead world.
When the Mariner pictures came by, all it showed was craters just like the moon. It was kind of a big disappointment. It didn't show any indications of canals and past civilizations. It was a letdown.
For the public who had grown up with this idea of Mars as a place that could be thought of as another Earth, that whole Martian empire was just smashed to red dust in an instant. This planet died. You know, Mars died. Mariner 6 and 7 come along. Mariner 6 sent back 75 images, Mariner 7 sent back 125, but still very limited, you know? It's just a flyby, right? So Mariner 9 comes along in 1971. Public interest is starting to wane. There's a certain ennui about, we've been there, we've done that, what's the big deal?
Unfortunately, as we approached the planet, we realized that there's this huge dust storm that was pretty well masking everything on the surface.
Mariner 9 was reprogrammed by NASA to hold back.
We had no idea how long the storm was going to last, and this was critical because we were using up resources on the spacecraft, and we were getting a little concerned. The dust storm lasted about 3 months. Fortunately, the planet started to clear. And it revealed all these incredible geologic features. It was a geologic wonderland.
There are channels. There are canyons.
There's this huge canyon that was as long as the United States is wide.
There were things that really shook our foundation. And Olympus Mons is that object. If you stuck it on the United States, it would cover the state of Missouri. The top is almost poking out of the atmosphere of Mars.
Mars is just an incredibly different planet from what we had expected. You could see winding channels and teardrop-shaped islands. Everything you could tell had been molded by some flow. The only reasonable expectation was that these were eroded by large water floods.
You see deltas, like the end of the Nile Delta, that flowed into a low area which must have been the ancient ocean of Mars.
I mean, it was beyond anybody's expectation, even the canal builders.
Mars was a blue planet in its past. The question now is, was that enough to start life? We need to go to Mars with a life mission.
The next mission to Mars was going to be the Viking mission. Now, this was the most ambitious mission that had ever been launched to Mars. It had not one but two orbiters. More than that, for the first time ever, NASA was going to attempt to land a craft on Mars. These were two separate landers, each of which had high-tech stereo cameras, a robotic arm. Perhaps most importantly, though, they had the science experiments that they hoped would detect life. Nothing like this had been tried before.
People that had to invent everything. Heat shields, parachutes, throttleable engines to land. We had to invent it all as we went.
T-minus 10, 9, 8, 7,
This is like the first cathedral, the first Renaissance voyage over the oceans.
2, 1.
But it's to another planet.
Ignition.
That's big stuff.
Liftoff. Liftoff. 30 minutes after.
This was the culmination of years and years of work. So it was a lot of this as we watched it go up, but it went up just beautifully. Well, between the launch and arrival at Mars was about 9 months.
We had no idea what to expect, even some very basic things, like what was the footing like? Were we going to sink into a meter of dust?
Good roll, attitude hold. Be close to mortar fire. Firm mortar fire.
There's no question whatsoever that landing on Mars is one of the most difficult technological jobs that the human species has ever tried.
ACS confirms coordinate transformation change.
We released the lander.
UHF minus 105.13 is in sync.
And at that point, it is going thousands of miles an hour as it hits the Martian atmosphere.
59,000 feet coming up on mortar fire.
So the air shell slows you down. You're still going faster than the speed of sound.
Mortar fire. Lander confirmed parachute deployed. 1, TM2.
Then the supersonic parachute is deployed.
Leg deployed.
At 1 mile in altitude, the parachute was jettisoned.
So then we have to fire the engines all the way to the ground. We were holding our breath each and every moment. And it had never been done before.
ACS is close to vertical. 8 feet per second. ACS is green, 1.5 degrees per second max. Touchdown, Whit. Fantastic. 16 kilobits. Yes, we have a touchdown time of 12 hours, 12 minutes, 0.07 second.
What we knew when it landed on the surface was only that a signal was being transmitted. We knew nothing else. We had to wait 40 minutes.
Waiting for the data to start coming up.
The lander camera, it basically scanned like this.
And there's the first piece of information coming in.
Strips of the picture became available little by little by little.
Oh, more, a few rocks.
Oh, that's beautiful. May not look like much, but it's lovely.
We started seeing some dirt, then we started seeing some rocks.
Oh.
Then we started seeing more rocks.
It's just incredible to see that Mars, is really there.
Then we started seeing the footpad.
Seeing that first picture back was just thrilling. It was revolutionary. I felt this was a more thrilling moment than Apollo 11. Some hours later, the first image of the horizon comes in, and that did elicit gasps.
Well, the first pictures from each of the two Viking landers were each moments in human history to be remembered. They were geological snapshots into the workings of another world. It was a world with climate. We saw frost condensates form on Mars. We saw the sunset. We took early morning sunrise. We watched dust storms over the period of hundreds of sols. It's not easily forgotten.
We are the only generation that will ever explore the solar system for the first time. When we landed successfully on Mars, humanity had for the first time become a Category 2 species. A Category 1 species is one whose sphere of influence is only its planet and its moons. A Category 2 species reaches out and discovers what's in its solar system.
We still knew there was everything ahead of us. We were just sort of dying to get our hands into the soil, so to speak.
We wanted to find out if there was life on Mars. Well, how do you do that back in that day?
I understand that when proposals were submitted to send experiments to Mars, that one guy had submitted a proposal of just putting a little pan of food out there.
The life science experiments for Viking were fairly basic in design, but very ingenious.
We humans, we breathe in oxygen, but we exhale CO2. Plants breathe in CO2 and they release oxygen. In other words, metabolism. The biology experiment on Viking had 3 separate investigations, and each one was testing for a different type of metabolism.
When NASA accepted my experiment, we called it Gulliver, because it was going to a far-off place looking for tiny little beings. But NASA changed it to a much more serious name, the Labeled Release Experiment. I hated it, I really did. Such a dumb name. It took 12 days after Viking landed before we conducted the first experiment. The Viking arm extends out about 10 or 12 feet from the spacecraft. It then is dragged back in, collecting its sample, which it puts into a sample distribution box. Samples are then distributed to the individual experiments. The experiment ran for 7 days.
To say that there's life on Mars would be an astronomical discovery. Probably the greatest discovery ever. It was 10 days before the first data came in from the labeled release experiment. I was surrounded by several members of the team, including Gil. And I hit the print button, and we all waited. And then all of a sudden, in a flash, there were the data points, and it was a positive response. I was stunned. My God, it's positive, I said.
That's life, I know it when I see it.
It was clearly a positive response. No questions about it.
It appeared that there really was life there.
I sent out for cigars and champagne. I had all 10 or 11 people sign of that first graph that came down, on which I wrote, "Tonight, it all began tonight, it all began tonight."
Suddenly, everybody on the Viking mission became a biologist, and nobody was willing to say that that was life. They all had alternative explanations for it.
The general interpretation was, well, there must have been something geologic or some property of the soil on Mars that gave this positive result.
Exotic things like superoxides. I didn't even know what a superoxide was.
Maybe it had something to do with the presence of perchlorates, which are a particular type of salt, and they can cause some funky things to happen in soil. That could have had some effect on the results.
The second factor was that another experiment, which was Norm Horowitz, did not see important responses to what they did to the soil.
At least there are no data, and it's because there's so...
Norm Horowitz was far more skeptical, and he was absolutely convinced there wasn't any life on Mars.
We don't know.
Norm Horowitz's position was very strange.
There's no evidence that there is
He said, not only is there no life on Mars, but we now know why there's no life on Mars. It has no liquid water. I feel he was not objective. Scientist has to keep an open mind.
The concept of saying, okay, we found life was all about each of these experiments we're going to be able to say, I found life, I found life, I found life. So you had to have positive indication for each one of those.
The other two life detection tests were negative.
Skepticism mounted, except in the case of...
NASA didn't entertain that the error may have been with the instrument looking for organic matter.
We don't know that yet.
We have not definitely proved that Viking did not find life. Unfortunately, the people who were the highest ranking scientists had their say and drowned out the people who were saying, but.
Zilch. There was nothing.
So Norman Horowitz concludes at the end of this process, it is now virtually certain that the Earth is the only life-bearing planet in our region of the galaxy. We have waked from a dream. We are alone.
Well, how does he know?
I sent him a letter trying to convince him, and he sent me a letter back saying, Gil, what you said is all nonsense. There's no reason for us to communicate any further. And that broke my heart.
The Viking results certainly caused a hiatus in Mars exploration, and even longer hiatus in looking for life.
Picture will cover an area of approximately 176 miles.
We lost the Mars program for a whole 20 years.
What are we going to do? We see H, E, L, E stand out.
Ladies and gentlemen, good afternoon. Welcome to NASA headquarters and what promises to be a very exciting and controversial news conference today.
So if I can introduce the team, first, Everett Gibson from the Johnson Space Center. He's a geochemist with over 20 years of investigations in lunar sample work.
In 1984, scientists were in the ice fields of Antarctica. They found a rock that had a slightly unusual color to it. And it was picked up and brought back. And then the scientist at NASA was able to analyze this rock. And he realized the gases that were trapped in this rock matched exactly the gases that the Viking spacecraft had measured from the surface of Mars. He had a smoking gun. We had a rock from Mars.
What I would like to do this afternoon is lead you through our story, which is a bit of a detective story.
We had a rock from Mars that in an area it had these carbonate globules. So what we then did is take some of the carbonate globules, gave them false names, sent them to Stanford University, They did the analysis. A spectrum appeared, organic matter in our samples.
I'd like to welcome everybody here today. It's an unbelievable day. It's very, very exciting for me.
Not just one sample, multiple samples.
Their dedication, knowledge, and painstaking research
We worked on it for 4 years.
have brought us to a day that may well go down in history for American science, for the American people, and indeed humanity.
One evening, we were looking around, scanning, looking. Suddenly, we started finding these segmented structures.
And that caught our attention.
These segmented structures look like a desiccated worm.
If I can have the next slide.
If he had a segmented worm and you took all the water out of it, he would shrink and he'd leave this little morphology that was left.
The simplest explanation to us is that they are the remains of Martian life.
This was a major discovery.
I can honestly say that it's undoubtedly the most exciting thing I've done in my 27 years as a scientist.
And so we put our data out there and let the people shoot at it.
Questions, please? Jim.
If this is correct, if you have found life once existed on
Additional
Mars,
work needs to be done.
I think in science, consensus builds slowly.
If you could characterize a smoking
Who is to say that we are not all Martians?
David Chandler from the Boston Globe. One of the investigators of the Viking life detection tests has maintained the labeled release experiment did in fact produce evidence of current life on Mars. Do you think there will be a re-examination of the results of that experiment?
Okay, and I think I'll handle that one. This result that you heard about today has only something to say about the possibility of life early in the planet's history. Not really about...
Good afternoon.
Presidents don't tend to make big speeches about space, so it took over the media.
If this discovery is confirmed, it will surely be one of the most stunning insights into our universe that science has ever uncovered.
But then when it started becoming more and more scrutinized by other scientists taking a look at it, it became more and more generally accepted by the community that these were actually features that were left behind by a geological process and not by life.
I am determined that the American space program will put its full intellectual power and technological prowess behind the search for further evidence of life on Mars.
Liftoff with the Mars Observer and America's return to the Red Planet.
Even though that conclusion is still under a large amount of debate and question, it did revitalize the interest in Mars.
We're good symmetrical burn on all 6 satellites.
This story didn't have to be true for people to get inspired. Just the idea that there might be life on Mars was probably enough to get a bunch of people inspired.
Those findings stimulated a lot of attention to Mars, and that was beneficial.
The question was asked, do we go to the surface with some new thing? Do we put outriggers on a lander to make it tougher? Or do we move? They said, okay, what would science want? And science said, we want to be mobile and go. And so we went for it. 2 rovers, 2 landing sites, 2 payloads.
Spirit and Opportunity were 2 solar-powered robots that would have the ability to rove around and analyze rocks and soil on Mars.
And liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Now, in the post-Viking era, the mission shied away from explicitly searching for life and instead went for the next best thing.
T+20 seconds.
Spirit and Opportunity never started out with the mantra, let's go find life.
We're approaching Mach 1.
But if you were to ask the astrobiologists, give me a definition of life so that I could go out and find it in the solar system, the key ingredient is water.
Positions look good.
So Spirit and Opportunity were looking for water-modified rocks.
Jettisoned all 6 solids and we've ignited the other 3.
The whole concept was let's follow the water.
T+20 seconds.
And good evening from the flight deck.
At this time, we are approximately 5 minutes, 53 seconds from the equator of Mars. The weather today at the landing site is expected to be fairly mild, with temperatures averaging about minus 15 degrees C, and there is no chance of rain today. At this time, we invite you to sit back and enjoy the landing. It's going to be an e-ticket ride. 2, 1. Vehicle is now at the top of the Martian atmosphere. We are moving at a speed of 12,187 miles per hour. Entry plus 30, altitude 60 miles.
Parachute deploy has been detected.
We have positive indication of parachute deploy.
Heat shield separation, self detected.
We have confirmation from the spacecraft that the flight software has attempted to genesis. Time the rocket
has fired.
We have confirmation that the rocket has ignited. We are now awaiting confirmation of positive signals bouncing on the ground.
Getting a bounce signal.
Getting a bounce signal. Indicating confirmation the spacecraft is bouncing in the line on Mars. However, this bouncing
signal has stopped. Hold on.
We have a momentary loss of signal as the spacecraft is bouncing on the surface. It is difficult to maintain lock. We need to reacquire the signal to have positive confirmation of a safe landing.
We're seeing it on the LCP. We're on Mars, everybody.
Spirit landed in a region called Gusev Crater.
During the landing site selection process, we used a camera that was on the Mars Global Surveyor, and it trained and took pictures of the ground. Gusev Crater has a drainage channel that extends for thousands of kilometers through the ancient highlands, and looks like it filled that crater up with a lake. This was a location where sedimentary rocks that could tell us about the environment when it was active would be. We got images pretty quickly.
We thought it might be landing in the middle of an old lake. Unfortunately, we got there and all we could see basically was volcanic stuff.
Gusev was basically a basaltic plain, which is lava flow.
So if the lake had ever been there, it had been covered by volcanic materials.
We were crestfallen that none of our predictions about what materials would be there were, that we were wrong. The opportunity was completely different.
Opportunity really hit the bullseye because it landed in a place called Eagle Crater, in which Mother Nature has done you a big favor. At some point, she slammed a meteorite into the surface of the planet, excavating this big hole, and basically gave you this archaeological dig, if you will. You land in the middle of it, and all you gotta do is look around, and here's the history of Mars.
For geologists, outcrops are currency. And we saw sedimentary rocks.
When geologists go out in the field here on Earth, and they want to look for layers of sediment that have accumulated over time. This is literally the historical pages of the book of the Earth. At this level was where the dinosaurs were, and at this level they died, and at this level new life became. You can just read that book of history That's what we found on Mars.
Because they had the robotic arm and they had instruments on the arm, you could find out exactly what they're composed of.
There was this treasure trove of information that just kind of flooding back. These were not igneous rocks, these were sedimentary rocks that would have been formed by liquid water. They had gone through periods of groundwater that had changed their composition, and it was a classic sedimentary sequence that we've seen on the Earth in many places.
And this is where it really gets interesting.
We see these little bead-like things in the soil. We thought, what could these be? I mean, people started conjecturing, but when we put the infrared eyes on them, we can see iron and oxygen in them. We're thinking, holy crap, Batman. We found hematite.
Hematite is a mineral here on Earth that's formed in water, and a lot of it, in moving water, that allows this mineral to be formed. And they were all over the place.
Holy gosh. We found the Holy Grail. So the whole point of the Mars exploration rovers was roving. We want to move.
Now, the Spirit and Opportunity mission was expected to last just 90 days, but as both of them traversed the Martian surface, they soon blew right past that.
We hopped from crater and crater and crater.
We drove tens of kilometers. They outdid their warranty by factors of hundreds.
We're several years into the mission that we had real trouble with Spirit. Spirit had lost one drive wheel. In doing so, we got stuck in a sandy crater, and it was very difficult. And that was the end of Spirit, yeah.
But Opportunity just shines like a radiant star, because this rover keeps going and going and going.
Opportunity really began to show evidence of past water.
We started to see the kind of mineral signatures that were the stuff of dreams, that support water as a persistent liquid phase.
Water that formed the Burns Formation.
Deposited by water.
River flows, groundwaters.
If you were there when the water was there, you could drink it.
This is just this ongoing saga of water. Water, water everywhere. Then in 2012, a new rover drops into the party. Curiosity, equipped with a drill and carrying an entire laboratory on its back. This machine rolled into town and immediately changed our view of the red planet.
As we dug into the soils, and we found, to our delight, it had carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. That's everything between these two fingers. All the right stuff that life is made of is on Mars.
Meanwhile, after 15 years on the surface, Opportunity had covered a record-breaking 28 miles, documenting every step of the way. It's this unstoppable machine. It just keeps driving. And then in June of 2018, here's a dust storm in the distance. It turns out to be a whopper.
The sun was almost blacked out. And at that point, there was no power getting to the panels, and we've lost contact.
4 months, we don't hear anything. It's gone silent.
We all just kind of held out hope.
We tried for months and months and months until there was just nothing. And at that point, you eventually, you say that's the end, yeah.
We had one final day where they called the team out to JPL, the Jet Propulsion Laboratory, where anybody that wanted to come and be there when they sent the final commands could come. We had all gathered in this area called the Dark Room, overlooking mission operations, and we're watching the flight commanders sending off the last commands to the rover. We did basically 4 final pings. The light time delay comes and goes. We got no signal, and everybody just kind of sits there in silence. And then the manager of the mission, John Callis.
This concludes operations for MER-1, spacecraft ID 253.
Says, thank you for your 15 years of service.
Thank you.
But, this is the end, so, this is MER signing off the net.
MER project off the net.
In the dark room, it was just silent, and everybody's kind of looking around, and we're like, this is it. This is actually the end. It definitely led to a lot of tears.
When we look at these missions, it's an enormous legacy. What we know about Mars really has been built up over a series of missions, and we've learned really spectacular things in each and every one of them.
We've gone from this first rapid flyby that sent back 22 images to today, we've discovered that it's not a dry, dead world.
4 billion years ago, if I stood on Olympus Mons, I would see a vast ocean and begin to see the land. And maybe on that land was vegetation.
Mars was wet, warm, wonderful, and there's no reason to believe that life did not develop on Mars 4 billion years ago.
The story is getting sharper. Water, habitable environments in the past, organic molecules. This is a new Mars. The story's only going to get better.
I am now 95 years old. Never give up. Never, 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 etc.